Welcome to Skill 11, finding trig values. We're going to be talking more specifically about finding trig values that are not on the unit circle. So let's start by just reviewing how we work with angles in both degree mode and radian mode. For each of these angles, we're going to draw the angle in standard position. We're going to find the reference angle, positive coterminal angle, and a negative coterminal angle. So what I'm going to do before I do any of that is I'm going to draw this. Negative 470 degrees, 73 degrees rather. We're going to start moving in a clockwise fashion. Negative 470 degrees, 73 degrees, that's more than one time around the circle. So I know I'm going to have to go all the way around once. So what I'm going to do is take 473 minus 360. I still need to go 113 more degrees in the negative direction. So let's see, that's going to be a little bit more than 90, so about right here. So there is my angle's terminal side. So now what we need to do is figure out the reference angle. So this is going to be where our reference angle is. And I told you that to go from here to here was 113. So if I take 180 minus 113, I find that this angle, this reference angle, is 67 degrees. Okay. So that's how I'm figuring that out. Okay, so now we are asked to find a positive and a negative coterminal angle. All right, so let's do the negative one first. So to do that, I'm going to take negative 473. Normally I would subtract 360, but since I know this negative 473, even when I add 360, is going to take me to a value that is still negative. That gives me negative 113 degrees. And for a positive one, I'm just going to take that negative 113 and add another 360 to it. That's going to give me 247 degrees. Okay. Now I'm going to look at a radian angle. So if I look at this one, 13 pi over 7. So I'm going to think about this fraction 13 sevenths for just a moment. 13 sevenths is just a little bit less than 14 sevenths. We know that 14 sevenths is 2, so 14 pi over 7 would be 2 pi. 13 pi over 7 would just be shy of 2 pi. Okay, so when I do this, I'm going to go counterclockwise. I'm not going to go a full 2 pi, but I'm going to go really close. So about right here. There's my angle. My reference angle then is going to be this distance here. Well, remember 13 sevenths. If I take 1/7 more, I get 2 pi. So this reference angle is pi over 7. Now I need to find a positive coterminal and a negative coterminal. Okay, so because that reference angle of pi over 7, if I had drawn it going downward, that would be my negative coterminal. So that's like 13 pi over 7 minus 14 pi over 7, which is 2 pi. So my negative coterminal is negative pi over 7. For a positive coterminal, I'm just going to take 13 pi over 7 and add 14 pi over 7 because that is the same as 2 pi. That's going to get me 27 pi over 7. There we go. Okay, so now let's talk a little bit more about, let's review rather, how to determine where an angle is going to lie given some information. Okay, so here we're told that cosine of theta is less than 0 and tangent is less than 0. So I'm going to draw my all children take showers and use some elimination. So cosine is less than 0. Cosine is negative. That eliminates quadrants 1 and 4 because those are where cosines are positive. Tangent is also negative, which means it can't be quadrant 3 because quadrant 3 tangent is positive, so we must be in quadrant 2. On the next one, we know, let me draw this in. We know cosine is less than 0, so that eliminates quadrants 1 and 4. Cotangent is undefined, so cotangent is going to equal cosine over sine. And for it to be undefined, that means sine has to equal 0. Sine equals 0 when y coordinate is 0. So when I look at when my y coordinates are zeros, that's going to be here and here. But since we know that cosine is negative, we can't be here. So we are going to be on the negative x-axis. Okay. All right, so now how do I find the exact value of the 6 trig ratios for some angle alpha if we know what ordered pair it goes through? First of all, exact values. That means no decimals. Okay, so let's go ahead and do this. So if I do this with 5, -3, I'm going to plot that point, 5 over -3 down. Our angle alpha, this is the angle alpha. When we look at this, we are going to figure out what the hypotenuse is first. So we use Pythagorean theorem, 5 squared plus -3 squared equals c squared. And we get radical 34 equals c. Okay. Now that we know that, we just find our 6 trig ratios. Sine alpha is going to be our opposite over our hypotenuse, so -3 over radical 34, which is the same as -3 radical 34 over 34. Cosine of alpha is going to be our adjacent side over the hypotenuse, so it'll be 5 over radical 34, which is 5 radical 34 over 34. Tangent of alpha is going to be opposite over adjacent, so -3 over 5. For the cosecant, we take the reciprocal of sine. I'm going to use the unrationalized version because when I flip it upside down, it will be rationalized. Secant of alpha is going to be the reciprocal of cosine, radical 34 over 5. And the cotangent of alpha is going to be -5/3. Okay. All right, I'm going to pause here and let you try the next one out, and then when you've tried it out, unpause the video and see the answer. And if you did this problem correctly, you would have gotten the answers that you see on your screen. So pause the video, check your answers, and then when you're ready, move on to the next part. Okay, so on this one, we're told that the sine of alpha is -3/5, and tangent is less than 0, so tangent is negative. Use this information to answer the following questions. So first, what quadrant will alpha be in? So we're going to do our all children take showers. We know that sine is a negative value, so it can't be quadrants 1 or 2, because that's where sines are positive. Tangent is also less than 0, so it can't be quadrant 3, must be quadrant 4. So what I'm going to do is draw a reference triangle in quadrant 4. Here is my alpha. We know that the sine of alpha is negative 3 over 5. So the 5 is the hypotenuse. The negative 3 is the opposite side to that. Okay? Now the reason I know that the net 3 had to be the negative number is because we're going down in the y-axis. So that's why. Okay, so Pythagorean theorem is going to tell us the missing side. So we're going to have negative 3 squared plus b squared equals 5 squared. B squared is 16. So b is 4. All right, so now we know that side, so we're going to find the 5 other trig ratios. Remember, we already knew sine of alpha, okay? So I'm just going to write it again. Sine of alpha we know is the negative 3 over 5. We already knew that. Cosine alpha is our adjacent, which we just found, 4/5. Tangent of alpha is going to be opposite over adjacent, negative 3 over 4. Cosecant, reciprocal of sine, secant, reciprocal of cosine, and cotangent, reciprocal of tangent. Okay. For this next one, we're told that secant of alpha is equal to negative 3 over 2. What I want you to know about that is that implies then that cosine of, I said alpha, I meant theta. That means cosine of theta rather is negative 2 over 3. And then tangent is still greater than 0. All right, so which quadrant is it in? All children take showers. Our cosine is a negative number, so it can't be quadrant 1 because everything's positive there. Can't be quadrant 4 because cosines are positive there. Okay? We also know that tangent is greater than 0, which means it has to be quadrant 3. So quadrant 3 is where we terminate. Okay? All right, now we're going to draw our reference triangle in quadrant 3. On this one, we know cosine is going to, so here's our theta. Cosine is negative 2 over 3, so cosine is adjacent, so negative 2 over hypotenuse, which is 3. So using Pythagorean theorem, we're going to figure out the missing side. So b squared is going to be 5, so b is radical 5. But look where we are. We're going in the negative direction on the y-axis, so we're going to put a negative on that. That's one mistake people make a lot, so please make sure you check that. Labeling my sides, I know this is the hypotenuse, opposite, adjacent. So now we're going to find the other trig values, okay? Sine theta is going to be the opposite over hypotenuse. Cosine theta, we already know that'll be negative 2/3. Tangent theta is going to be, it'll be positive radical 5 over 2 because we have the two negatives that would divide out. Cosecant theta is going to be negative 3 over radical 5, which is negative 3 radical 5 over 5. Secant theta we know is negative 3 over 2. Cotangent theta will be 2 over radical 5, which is 2 radical 5 over 5. All right, trucking right along here, we're going to try this next one. I'm going to let you try this on your own. Pause the video, try it, and then check your answer with the video. All right, so now unpause, or pause if you need to, but here are the answers that you should have gotten for this one. So check your work, and then if you have questions, we can discuss it further in class. We will be skipping this next one, and I think this one is just a little bit more of the same, so I'm gonna just quickly talk through it. So for this one, they don't scaffold it out, so we have to know what quadrant we're in first. Tangent is negative, so we're going to eliminate 1 and 3. Secant is greater than 0, which implies that cosine is greater than 0, which means it's not quadrant 2, must be quadrant 4. Okay, so we know this is our theta. Tangent would be opposite over adjacent, so negative 4 over 3. We need to find the cosecant and the cosine, so we must know the hypotenuse. 3 squared plus negative 4 squared equals c squared. So c is going to be 5. Alright, so we're only asked to find the cosecant of theta. So cosecant, remember, is the reciprocal of sine. So if I look at sine, sine would be the opposite, which is negative 4 over 5. So we're going to have 5 over negative 4. And then cosine of theta is going to be the adjacent over the hypotenuse. Okay, that should do it. Hopefully now you will be able to practice some problems on your own.